Hello friends, welcome to part 2 of BSc third SEM C5 paper solution mathematical physics of Dibrugarh University 2022. Right, so in the last video we have solved up to question number 3b. We have solved up to question number 3b. Now we're gonna start with question number 3c. Okay, so now let's start. Now you see, this is question number 3c. This question was already asked in 2020, okay, as a MCQ, but I have explained how to obtain this result. Okay, so I will provide the link in the description box of that video. Just go and watch. Okay, and also I have proved this one also in that this one also asked in 2020, right? So now let's come to this question. Okay, now we are to prove this. Here you see, let me go to the solution directly. So here you can see this this is called Bessel's polynomial. Okay, so from this one, if we put n is equal to half in 1, we will get this j half this of x, right, is equal to this expression we're gonna have, right, on putting n is equal to 1 by 2, right? And if you simplify this result, then you're gonna have this. Okay, you're gonna have this result. And remember that gamma function of half is pi, so I have used here. Okay, similarly, if we use if we put n is equal to minus half, then here we're gonna have j of minus half of x, right? So this is equal to this one, and simplifying this we're gonna get this result. Okay, so now you see, what do we need to prove? We need to show that the half of x whole square plus the minus half of x whole square. So this is the left hand side, right? So now let's put its result. This is what the half of x, that is root over 2 by pi x sine x, as there is whole square, so let me give here a square, then plus, let me just adjust this. Okay, and here we're gonna have root over 2 pi x, sorry, this should be cos x, that's what we're gonna have. Now squaring and adding, what we're gonna have here, 2 pi by x, and if there is taken common, sine square x plus cos square x, that's what we're gonna have, which is equal to, this part is equal to 1, so that's why this is our answer, 2 by pi x. This is the right hand side, right? Hence proved. So hope you have understood this. So that's how we can prove this. This is the solution of question number 3d. Or okay, there was another question. I have given the link of that in the description box of question number 3c and d. There were two questions in d. This one or another questions, which one already solved in 2020 paper. So that's why I have provided a link instead of explaining that again. So these are twos. Okay, if you can't recognize them, write this. So I hope, being a student of BSc, you can simplify these kind of things. Okay, so now let's move on to next question. Now we are to solve this question. What is this? 0 to infinity, 4th root over x e to the power minus root over x dx. So we're gonna evaluate this integral. So I have taken this one as I in order to evaluate this. So here you see, let us put let us put root over x is equal to t, suppose, and then we're gonna have x is equal to t square, right? If you differentiate both sides with respect to t, then what you're gonna have, dx by dt is equal to 2t, and hence you're gonna have dx is equal to 2t into dt, right? So hope you have understood this. So we have got dx is equal to 2t dt, right? So hope you have understood. So this is suppose 1, this is suppose 1. So now using this in 1, then what we will get, now you see, square root of 4, 4 root of x, it can be written as root x whole to the power 1 by 4, right? Sorry, whole to the power 1 by 2, root x whole to the power 1 by 2, because square root of 4th root of x is x to the power 1 by 4, which can be written as x to the power 2 1 by 2, then again x to the power 1 by 2. So that's it, right? So x to the power 1 by 2 is, I have written as root over x. So now you can replace this root over x by t, then you will get t to the power half. So this can be written as t to the power half, right? Integration from 0 to infinity. So let me write, this is 0 to infinity, then e to the power minus root x is t simply, so dx is your 2t dt. So let me write 2 outside, just wait, t dt, let me write the 2 outside the integral. Okay, so doing that we get this. So now what we can do here, you see, if you multiply this 2, then what we're going to have, 2 integration 0 to infinity t to the power minus 3 by 2 e to the power minus t dt. That's what we're going to have, right? So now you can see by definition of definition of gamma function. What is the definition of gamma function? Gamma function, here you can say gamma of n is equal to integration of 0 to infinity x to the power n minus 1 e to the power minus x dx, right? That's what we get. So here 2 integration 0 to infinity, so t to the power minus 3 by 2 can be written as minus 5 by 1 minus 5 by 2. You can write 1 minus 5 by 2. Instead of writing that, it's gonna be better if I write, yes, that should be plus 3 by 2. Okay, so I made a mistake here, plus 3 by 2. So that's why 5 by 2 minus 1, it can be written as 5 by t to the power 5 by 2 minus 1, then e to the power minus t dt. So comparing with this, so this is gonna be gamma 5 by 2. So hope you know how to evaluate gamma for root 5 by 2. So number 2, so gamma 5 by 2, we know that gamma of n plus 1 is given by n into gamma n, right? So similarly, so gamma 5 by 2 is nothing but gamma 3 by 2 plus 1, and which can be written as, according to this identity, 3 by 2 into again gamma function, this is not square root, gamma function, gamma of 3 by 2, right? Again 3 by 2 can be written as half plus 1, so that's why 3 by 2 half, again gamma of half. Gamma of half is here we're gonna have 3 by 2, then 1 by 2, and gamma of half. Gamma of half is square root of pi. This is gamma of half, so that's gonna be square root of pi. To this to cancel, we're gonna have 3 by 2 into square root of pi. So that is our answer. So hope you have understood this. Now let's move on to next question. This is question number 4. Okay, so now you see, in question number 4 we needed to evaluate this, or we had to prove this one, right? So this was also asked in 2020, so I have proved this one as well in that paper. so that's why I'm not going to show it again. I'm going to provide the link of those 2020 papers videos. Okay, all the links will be given in the description box. Okay, now let's go to the next question. So this is the question number 5. Here you are asked to find write some definitions, okay, and their examples. So I'm going to give you the answers, okay, directly. I'm not going to explain these kind of things, theoretical things. So you will if you read those, you're going to understand that. So this is the answer of question number 5a. So here are the definitions, right, and examples are also there. Okay, examples are also given. So now just you read it. Okay, and now this is 5b. What was the question 5b? So this is the question number 5b. Find the maximum error in magnitude in the approximation of this function, and here over the rectangle x minus 3 is less than 0.01 and mod of x minus 2 is 0.01. okay, so that means we can say that let me clean these things, just wait. So this is the given function here, you can see. So over this rectangle, so this is nothing but your del x error in x, and this is nothing but your del y error in y. And you can say that here you can put x is equal to 3 and y is equal to 2, right? X is equal to 3 and y is equal to 2. Okay, that means these are the values with errors, right? So in order to get the error, you have to subtract the original this value with error from the original. Okay, then you get the error, right, del x. So that's how we do, right? So in order to find the maximum error, so that is del f max. So in order to calculate this, we use this formula: partial del f by del x, partial derivative of f with respect to x into del x, then partial derivative of f with respect to y into del y, right? So if you differentiate this with respect to x partially, then you have to consider y as a constant. Then in that case, this x square going to be twice x, then minus xy. If you differentiate it, it's going to give you minus y, because derivative of x, that's 1. And here you see there is no x, so that's going to be 0. 3 going to be also 0 on differentiating. So if you put x is equal to 3 and y is equal to 2, if you put x is equal to 3 and y is equal to 2 here, it's going to give you 4. Similarly, if you differentiate f with respect to y, then you're going to get this answer, right? And so if you differentiate x square with respect to x partially, then it's going to be 0, right? So if you differentiate minus xy, then it's going to give you minus x. And if you differentiate this y cube, then here you're going to get 3y square, and there is half before it, so that's why 3 by 2. Hope you have understood. And if you put x is equal to again 3 and y is equal to 2, then you're gonna get this answer: x is equal to 3 and y is equal to 2. 3 by 2 into y square is your 2 square. So 2 cancels 2 square, and 3 to the 6, 6 minus 3, that's gonna be plus 3. So this is what we have got, right? Now let us use these values of del x, which is 0.01, del y, which is 0.01 again. So we have used those values here, and del f by del x, this is 4, del f by del y, this is 3. So we have used those values, and using those we have got this 2, and this is the error we needed. Okay, so hope you have understood this. Now next question number 6. So I couldn't solve this first one of question number 6. Actually I tried, but I couldn't deal with this boundary condition. So I actually, in order to solve this, I need more time, but you have exam tomorrow, so that's why I left this one. So I jump up to this question. So now let me go to this question. Here you see, so this is the question of 6.2. So again here, we have to consider u as product of capital X and capital Y. where capital X is the function of small x, capital Y is the function of small y, then here you can see, let's find del u by del x. So this is what we needed to find. Here when you differentiate u with respect to x partially, y keep y as a constant. Similarly, when you differentiate u with respect to y partially, then x as constant, differentiate y. Okay, then using these results in given equation, this given equation becomes something like this. Here you can see it takes the form of this. So now from here, if you simplify those, if you multiply these two, instead of multiplying these two, so divide both sides by xy. Okay, then you're gonna get this equation. Then it's gonna give you this equation, right? So now 2 is multiplied here and there. Then let me go to the next slide. Here you can see, so now this 2x is brought to the left side and this one is shifted to the right side. I have separated the variables, y on one side, x on other side, so taking both equal to k, right? So now this is equal to k, taking that we have got this equation. Now let us solve this equation, and this simplifies this, right? And integrating both sides, what we're gonna have, this k is constant taken outside, integration dx, then 2 is constant taken outside, x dx. And as you know, the integration of 1 by x is log x, so I have taken the constant, integrating constant in terms of log, right? So here we have got log x, kx plus x squared, and log c1. Now you see this kx plus x squared also can be written as log of e to the power kx plus x, because log e to the power x is simply x. Similarly, kx plus x squared can be written as log of e to the power kx plus x squared, because we have log here and there also. To remove the log from each term, we need to take in terms of log, so that's why, and doing so we have got this result, right? So what we have done here, you see, it can be written this way, log of e to the power kx plus x squared. Then if we use this rule that log m into log m plus log n is equal to log m into n, then it's gonna give you this result, log of e to the power kx plus x square into c1, right? And removing log from both sides, we get this result of x, right? So hope you have understood. This was nothing but your kx plus x square, right? So now let me go to the next slide. So here you see, similarly here I have taken this part of this equation. This is what we have taken, and if you simplify this, then you're gonna get this equation. Now again we have integrated, and again as we're gonna get here log, so that's why I have taken the constant c2 as log c2. Okay, and similarly this one also can be written as log of e to the power y square minus ky. Okay, so then again, if I can write this right hand side as log of e to the power y square minus ky plus log of c2, then again using this property, log of m plus log of n is equal to log m into n, we will get this result, right? And removing logs from both sides, what we're gonna have, just wait, let me clean these things here, just we're gonna get this result, right? So now putting the results of capital X and capital Y in equation number in equation 1. So here you see, so I have given this as equation number 1, so we have to put here x and y. We have got this is x and this is y, and using those two we have got this result, right? Now c1 and c2 I have written here as a capital C as a c1 and c2, so I have used capital C here instead of using this two constant. Product of these two I have taken as capital C, and e to the power kx plus x square into e to the power y square minus kx. If you multiply this two, then you're gonna get this e to the power kx plus x square plus y square minus ky you're going to get this result. Then from here you can take k common from these two terms, kx and ky, and k is taken common. We have got k into x minus y, and here we have got x square plus y square. This is the result, right? This is the solution of this equation number. This is the solution of this equation 6.2, right? Now let's move on to 6.3. So what was the equation given in 6.3? This is the equation given in 6. Sorry, this is one. Not one is not completed. I have done up to this point. This one I couldn't apply the boundary conditions here. I'm a little bit confused in this case. So that's why let's go to the third one. 6 of 3, equation number 3 of 6. So here is the equation. Again, we have proceed in the same way as we did in the first 6.2, and this is capital X is function of capital small x, capital Y is function of small y. So we have find del y, del u, del x, del u, del y, and we have got this equation. And then variable separable method, apply variable separable method, right? And separating the variables, y on one side, x on other side, we have got this equation. Then we have taken each term as equal to k. So now taking this one and this, we're gonna get this, right? And integrating this, solving this equation, we're gonna get log of x, kx, log of c1, and kx can be written as log e to the power kx, because it is again equal to k into x, right? So now again, using the property of log, you can write the right hand side as, if you use the property of log here, then you're gonna get this. So removing the log from both sides, we're gonna get the x, right? Similarly, taking this part of the equation, right, solving this, we're gonna get y is equal to this one, right? So now we have got x and y both. We have got both x and y, and we have put this in equation number 1. Let me write here. This is equation number 1. Now just wait, let me mention here, putting the results of capital X and capital Y in 1. We have got this, right? Now you see the solution u and can be written as u1 plus u2 as a series, sum of series. So that's why I have written this. And one more thing, one more condition is given, u of x comma 0. That means y is equal to 0. When y is equal to 0, is equal to your 3 e to the power minus 5x plus 2 e to the power minus thrice x. As there are two terms, so I have taken this solution as a sum of two terms. Okay, so in one we have taken k1 and another one we have taken k2, right? So at y is equal to 0, this part gonna be 0, e to the power 0 is 1, so that's why we're gonna get this answer. And we have expressed this one as a sum of these two. Okay, sum of these two. And doing so, again it is given in the question that u of x comma 0 is this. Now compare these two, this one and this one. Comparing these two, we have got this, right? Now here you see, compare this one with this term, then you're gonna get c1 into c2 is equal to 3 and k1 is equal to minus 5, right? K1 is equal to minus 5. So similarly, comparing this one with this one, we got this set of values, right? So now let me go to the next slide. So here you see, as we had here this one, u of x comma y, this one, as I have already told you that I can express this one as a sum of two terms. So I did here, I have expressed this one as this can be simplified as this. If you multiply this e to the power kx and e to the power half k minus 1 into y, then you're gonna get this result, and you can express this one as sum of these two terms, right? Okay. One more thing here. Wait. Now let us use this set of values in this equation, right? So u of x comma y, this result I have shown here. This result is written as a sum of these two terms, right? So now let us first here you see this set of values should be put in the first term, and this set of values should be put in the second part of this. Okay, so and doing so we have got this solution. This is our answer. So thank you for watching. Now you see we have two more questions, but I'm not gonna record now because it's already too late. That's why I'm not recording the last solution of the last question, or 2D Laplace equation in spherical coordinates and solution of 1D equation, Dilbert method. So that will be in the next part. So those who have exam tomorrow on 5th December, so it is already 5th December, 7 minutes past 12. Okay, so that means I should say today. Okay, so those who have exam on 15th December, not 5th, 15th December, that means today morning, so they should not wait for the last question. And those who are watching the video 1 or 2 weeks later, after this video is uploaded, they may wait for the next part. That means if they are new students in this semester, they can wait. Okay, and those who have exam today morning, so they should not wait, they should go for other solutions. Okay, thank you, see you in the next video, bye.